Okay, today we're working on our linear programming notes, and the steps are all listed here, and I'll use the steps as we go. These are application problems. You guys are always asking, how would we use this in the real world? And this is a great example of how algebra is used in the real world. So we're going to start by identifying our variables. And that's always, I just jump to the end of the problem and see what the question's asking, because whatever we don't know, that's your variables. And at the end it says, how many of each should be made to maximize profit? Well, each what? Well, we've got two blends. We've got deluxe and savory. So I'm going to say that X is the number of pounds of deluxe and Y is the number of pounds of savory. Okay, so we've just identified our variables. The next step is to do our constraints. And the constraints are the limitations. And we know that each pound of deluxe has 30% Colombian and 20% Arabian. Savory has 35 and 15. And we know what the profit is on each. This tells you how many pounds they have to work with. So that's our limit. We can't use more than those pounds. Those are really the main parts of our constraint. And what I do is I set up a table. I have my X and my Y. And remember, X is deluxe and Y is savory. Okay, and then I talk about my constraints. And my constraints are the amount of Colombian and Arabian coffee that we have. Okay, we're constrained by how much we have of each of those. And if I look at the Colombian coffee and Arabian coffee, okay, let's go to deluxe. It tells us that deluxe has 30% Colombian and 20% Arabian. So 0.3 for 30% X of my deluxe is Colombian, and 0.2 of my X, pounds of deluxe, 20%, is Arabian. And then for the savory, savory has 35% Colombian, so it's 35.35 times Y, and 15% Arabian, so it's 0.15 Y. And I know that if I add all the Colombian I use in deluxe and savory, that I cannot use more than 455 pounds. So that has to be less than or equal to 455. And the Arabian, no matter how much I use in both of those blends, cannot be more, so it's less than or equal to 250 pounds of Arabian, because that's all we've got to work with. Okay, so those are our constraints. So that was step B. Okay, then we're going to write the equation to be maximized or minimized. And in the problem it says we are going to maximize profit. Okay, we're going to maximize profit. We want to max the profit. And I know that I get on deluxe 125 a pound, so 1.25 times however many pounds of deluxe we make, plus $1.40 for the number of pounds of savory. Okay, so that's my profit statement. And that's what we're trying to maximize. And so in order to figure out exactly how many pounds of each that we're going to use, we're going to graph our constraints and see where they overlap. So I'm going to start with the Colombian coffee, right? And I'm going to graph that. So if I've got 0.3x plus 0.35y is less than or equal to 455. And the way I will find 2 points, this is like standard form, and so if I just plug in 0 for x, I can find a y, and 0 for y and find an x. That'll give me 2 points that I can connect and graph. So if I plug in 0 for x, I'd have 0.35y is less than or equal to 455. I divide 455 by 0.35 to get to y, and when you do that, your y is going to be 1300. Then if I plug in 0 for y, I have 0.3x equals 455. Divide 455 by 0.3, and I'm going to round to the nearest whole number, and that would give me 1517. So those are the two numbers that I would need to graph on for the Colombian. And then the two numbers I would need to graph for the Arabian, okay, the Arabian is 0.2x plus 0.15y is less than or equal to 250. If I plug in 0 for x and I take 250 divided by 0.15, I get 1,667. If you plug in 0 for y, take 250 divided by 0.2, you get 1,250. Okay, and I get these points first before I figure out what my scale is going to be on my graph. And it goes as high as 1667. Okay, so I'm going to say that the top point here is 2,000. In order for that to be 2,000, that means every box is worth 200. So 200, this is 400. This would be 800. This would be 1,200 and 1,600. And I'm going to do the same along the bottom. So this is by 200s. I'm changing the scale on my graph so I can fit it on in. So 400, 800, 1,200, 1,600, and 2,000. Right. So if I go with my Colombian, I have 0 and 1,300. So left and right 0 and up 1,300, which is going to be just about here, halfway between 12 and 1,300. And actually it's going to be, that's 400, so this is going to be a little bit closer. Yeah, there. And then 15, 17, and I'm going to go ahead and mark what that point is. This is 0, 1,300. I'm going to label my points as I go so I don't lose track. And then 15, 17 is going to be somewhere down in here roughly. And that's 15, 17, comma 0. Mark that point. And then what I'm going to do is I'm going to connect my points. I'm using paper for a straight edge here. And it's a solid line because my constraint is less than or equal to. If it was just less than, it would be a dotted line. And then I've got to figure out, it's an inequality, so I have to figure out the shading. So I have to pick a test point. And if the test point, and plug it into my equation. So I always check 0, 0. And then if I plug that back into my equation, I have 0.3 times 0 plus 0.35 times 0 is less than or equal to 455. And I have 0 is less than, because 0 plus 0 is less than 455. See how easy it is when you use zeros? If this is a true statement, that means I want to shade so that I include that point. And that point is right here. So I'm going to shade on this side of the line. And I'm only shading, I'm not shading all the way because we don't have negative numbers. It's only going to be up in this quadrant. Okay, because I don't have negative pounds of coffee. Okay, so that's that one. Okay, I'm going to do the same thing for this one. I'm going to plot my points. I have 0 and 1667. So this is 0, 1667. And I have 1250, 1250, comma 0. And I'm going to connect those 2 points. And I've got to see which side of that line I'm going to shade, so I'm going to test 0, 0. And I have 0.2 times 0 plus 0.15 times 0 is less than or equal to 250. So if 0 is less than or equal to 250, and that's true. So I'm going to also shade below the line here. And then my solution set is where these two shadings overlap. So I'm just going to color those in really dark. And I've got to identify all of the points, the corner points. Okay, this is a corner point, that's 0, 0. This is a corner point right there. This is a corner point here, but I also have a point here where where the lines cross, and I don't know what that point is. But in order to find that point, all I've got to do is find the solution for those two lines. Because remember, when wherever two lines cross, that's the solution for both. So I'm going to solve those two equations together as a system. So I have 0.3x plus 0.35y and equals 455. I'm using equals because I'm just looking for the point where the lines cross. I'm not worried about the inequality part of it right now. 0.2x plus 0.15y equals 250. And I need to multiply these by something so I can eliminate a variable. And I multiply the top by 2 and the bottom by -3, because that'll give me a 0.6 here and a -0.6 here. So that gives me 0.6x plus 0.70y. Is that right? 0.50y equals, let's see, 5, 10, 705. Oops. Oh, see, I was adding, wait. Oopsie. Okay, I'm still multiplying. So this is 0.7y because 2 times 0.35y. So you gotta pay attention to what you're doing. 2 times 455 is gonna be 910. And then negative 3 times all of these. So that's gonna become negative 0.6x minus 0.45y equals negative 750. These are gonna cross. So then 0.70y minus 0.45 is 0.25y equals 160. Divide by 0.25y, or 0.25, and my y equals 640. I'll plug it back into one of the equations to get my x. So if I plug it in that first one, I have 0.3, whoops, sorry about that. I have 0.3 times x plus 0.35 times 640 equals 455. And if you solve for x, you'll get x is 770. So that point is 770, comma, 640. Okay, that's my other corner point. So what I'm going to do is I'm going to take all my corner points, I'm going to circle that because that's one of my corner points. The corner points are all the places that are the corner of the totally dark and shaded in region. And what we're going to do is we're going to take all of those corner points and plug them into our profit statement. We want to see, we're trying to maximize that, so we want the one with the highest profit. So I'm going to start at 0, 0. And if I plug that into my profit, I have 1.25 times 0 plus 1.4 times 0. And that's going to be 0, because 0 plus 0 is 0. Then I'm going to try my next point. I'm going to 0, 1300. So I'm going to have 1.25 times 0 plus 1.4 times 1300. This is going to be 0, and 1.4 times 1300 is 1,820. Then I'm going to plug in the next one, which is my 770, 640. So I take 1.25 times 770 plus 1.4 times 640. And when you work that out, you get 1,562.50. And then my last point is the 1250. So if I take 1.25 times 1250 plus 1.4 times 0, that works out to be 1,858.20. And this is the largest amount. Okay, so that's the combination that will give you the highest profit. So that means I'm going to do 1250 is X. X is for the number of pounds of deluxe. So I'm going to do 1,250 pounds of deluxe and no pounds of savory. And that will give me the highest profit given the constraints of the number of pounds of coffee that I have. And so that would be your final answer. Okay, let's try one more. Okay. This time we've got a restaurant that's specializing in peanut butter and jelly sandwiches. And they've got two kinds, the double T and a traditional sandwich. Okay. First thing I've got to do always is identify my constraints. Okay, that was step A. So my variables. And we want to know how many of each type of sandwich will maximize the profits. So X is going to be the number of regular PB&J sandwiches. And Y is going to be the number of double T. Sandwiches. Okay, those are my variables. my constraints. We'll go back and look at the problem and see what I'm constrained by. I do know I'm going to have X as my PB&J, and Y is going to be my double T. Okay, and if I go up here, it tells you how much peanut butter and jelly each of them use. My constraint is I only have 250 ounces of peanut butter and 340 of jelly. So let's start with the peanut butter. And jelly is my second constraint. A traditional PB&J uses 2 ounces of peanut butter and 3 ounces of jelly. A double T uses 4 ounces of peanut butter and 5 ounces of jelly. When I add those together, I cannot use more than 250 ounces of peanut butter, and I cannot use more than 345 ounces of jelly. Okay, so those are my constraints. The next thing that we do is we write the equation to be maximized or minimized, and we are trying to maximize profits. Okay, so my profit on these, on a traditional sandwich, is $2, and on a double T, I make $3.50, and I want to maximize that. Okay, so I want the one with the highest value. Oops, this should be Y. Highest value. All right. Now we're going to graph the constraints. I'm going to start with my peanut butter. I have 2x plus 4y equals 250. So I have x and y. If x is 0, then y is going to be 62.5. And if y is 0, x is going to be 125. Okay, so those are the points I'm going to use to graph that. I'm going to do my jelly is 3x, this should be a plus, plus 5y equals 345. If my x is 0, my y is going to be 69. And if my y is 0, my x is going to be 115. So my values go up to 125. I use that information to figure out how I'm going to scale my graph. And I'm going to go up to, I think, 150 at the end. Okay, 150 divided by 10 is 15. So every block is going to be worth 15. So I'm going to make that 30, 60, 90, 120, and 150. And then do the same down here, 30, 60, 90, 120, and 150. And for this one, I have 0 and 62.5, so it's going to be right here. And 125 and 0. And notice I'm just getting as close as I can on estimating. Okay, I'm going to connect those 2 points. And then I've got to figure out where to shade, so I need a test point. And I usually will test 0, 0 because it's easy to plug in. So if I have 2 times 0 plus 4 times 0 equals 2, or this is supposed to be less than or equal to, is less than or equal to 250. I have 0 less than or equal to 250, and that's true. So I'm going to shade so that I would include the 0, except I'm only shading positive numbers because I can't have negative peanut butter or jelly. Okay, so that's in there. On this one, I'm going to plot my points. I have 0 and 69, which is a little bit above that one. And then I have 115, 0. These are really close to each other, but they do cross. So they're not the exact same line. Okay. And I'm going to shade below this one. So the darkened region is here. Oh, I forgot to write down my points as I was doing it. Okay, let's go back. Let's see, 0, this one is 0, 62.5. And this one is 125, 0. And then the pink was 0, 69. And 115, 0. And what we don't know is what this point is where they cross. And so I'm going to have to solve the lines of the system to figure out what point this is where they cross. And the test was 0, 0. I knew what the answer was. I should have done the test for you. It's less than or equal to. So 0 is less than or equal to 345, which was true. Okay, that's why I shaded below. Okay, now I'm going to solve the system. So I have 2x plus 4y equals 250. And again, we're just seeing where the lines cross, so I don't need to worry about the greater than, less than anymore. Equals 345. Okay, I'm going to get the y's to cancel, so I'm going to multiply the top times 5 and the bottom by minus 4. So I get 10x plus 20y equals 1250. And I have negative 12x minus 20y equals negative 1380. Now you could have chosen to eliminate the x's, it doesn't matter. I just chose to do the y's. These cancel, so I have negative 2x equals negative 130, divide by 2, x is 65. Plug that back into an original equation, so I'm going to take 2 times 65 plus 4y equals 250. And when you solve that, I'm skipping steps, but when you solve that, you get y equals 30. So that point is 65, comma, 30. So that's my corner point here, 65, comma, 30. Okay, and then the final step is to test all of our corner points. Now it's the corner points of the shaded region. So it would be this one, this one, this one, and of course 0, 0. So I always start with 0, 0. I'm going to plug it into my profit equation because I want to maximize profit. So 2 times 0 plus 3.5 times 0 equals 0. Okay, then I have 0 and 62.5. So I'm going to take 2 times 0 plus 3 times 62.5. And let's do that one real quick. This is 187.5. Okay, then I have 115, comma 0. So 2 times 115 plus 3 times 0 is 230. And then I have 65, comma 30. So I have 2 times 65 plus 3 times 30 is 220. So this is my max profit, which means I'm going to make 115 XSP traditional sandwiches. And, whoops, make sure you guys can see this. And 0 double T's. And that's your answer. And hopefully those two problems give you a good guide on what you need to do for linear programming.